Hello and thank you for subscribing to Infoverse Tech. This is a channel where we explore new trends and technologies, including Python programming, cloud computing, artificial intelligence, machine learning. And today we are talking about IoT or Internet of Things, and we are using Node-RED. That's a programming tool for wiring together hardware devices, APIs, and online services in new and interesting ways. This is a completely open source tool, and previously we have created tutorials on sending messages between two nodes and exploring some of the core nodes. And today also we'll be looking at switch, a core node called switch, and range, and both are key components of Node-RED. So let's get started. I'm here on the Node-RED homepage, and let me just go to the page for the core nodes. So here we've already recorded for change and inject, and I can share the links in the video here in the tutorial. Please revisit them. They start from very basic concepts and helps us to understand how Node-RED can be used to connect and create more complex flows. So we're going to look at switch, which is a node that allows messages to be routed to different branches of a flow by evaluating a set of rules against each message. The node is configured with the property to test, which can be either a message property or a context property. And we will also be looking at range, which allows us to explore or map a numeric value from one range to another, and the range node in particular is only dealing with numbers here. So for example, if you wanted to convert kilometers to miles, example speeds in Canada versus speeds in US, we can specify an input range and the target range, and you will see how the range function is able to map between different values. So another example or a use case could be normalizing incoming data points. So let's say we are receiving between values between 1 and 100, and we want them to be normalized to 1 to 16 as an example. So let's get started. I have my environment all set up here. So let's look at flow 3, where we are talking about the range function. So this by now most of the viewers would be recognizing this as the inject node. You have the two debug nodes, and I'll explain why I have one as original, one as ranged, and it's just to help differentiate between how how the range function is acting on these on the input. So let me click on the range function, and you can see that I have set it up as we discussed. So let me go through in detail. I have an inject node, and the idea is to convert an incoming number, which can be kilometers, into miles. So what we're going to do is, let's just select some number, let's say 100 kilometers in somebody driving in Canada. What does it convert to on US roads? Now we know that, as an example, 1 mile is equal to 1.61 kilometers. So let's use that concept. We're going to perform this activity on the message.payload. The action is to scale and limit to the target range, and there are other options as well, including scale and wrap within the target range, scale but drop message of outside input range. So very powerful ways we can play around to get what we're looking for. I'm using the scale and limit to the target range. So I'm mapping 1 to 161. So that effectively translates to 1 to 161 kilometers an hour as an example. And I want to map it to the target range, which is 1 to 100. So essentially what I'm saying is anyone going from 1 to 161 kilometers an hour, map it to 1 is to 100, which is actually 161 kilometers an hour translates into 100 miles per hour, and that's what the name I've given it, kilometers to miles. So let's save this. So original basically means that, as you can see, there's a direct connection. So whatever we are inputting here, it is shown in the debug window unchanged, but the other one, it goes through that range or mapping, and that's why it's called range. I'm just giving a name, and that's the one that goes through the range function. So let's deploy this and let's give it a shot and let's see if that works. So inputting 100, you can see that I'm getting 100 as the original input. That's 100 kilometers. And what am I getting on the ranged, which is 62, right? Which is right, because we've also selected the round result to the nearest integer. Let's uncheck that and let's see how that is dealt with. So if I put in the same number, you see that I get a range of 62.5. So it's very accurate in that sense. If you wanted a more accurate number, you can still use that as well. Let's take another number. So let's say what it means to be driving at 120 kilometers an hour, and let me deploy that. Let's see how much that converts into miles. So you can see that 120 kilometers is approximately equal to 75 miles per hour, and vice versa. So this is just a quick intro to the range function. You can see it's very powerful, and you can also, another use case could be like normalization. So let's say I have a number between 1 and 100, and I want to normalize that into just 16 data points, right, between this range. So let's see how that works, and let me call this normalization. Okay, let's redeploy and let's see how that works. So this is a number which is beyond that range. So let me select something that's within the 1:100, although that would also work. I can show you quickly. So let's clear this screen and let's run this, and you can see that with the 50 it mapped it to 8.4. Let me just make this, if I don't want that kind of accuracy, I can perhaps round it and see how that responds. So inputting 50, I get a 50, and on this side I'm limited to that range, which is 8. Let's put in a number that's greater than the range that we specified. It should take the highest range. So let's run that again. So it took 100, and on the mapping side it took the maximum that's possible because it's constrained within that range. So any number above 100 in the input range will result still in the highest value of 16. So that was a quick intro to the range function. I hope you understand and you can use it in your flows as well. So let's now switch over to flow 4, which is actually the demonstration for the switch function. So very similar setup to the previous one. You can see I have the inject node, I have the switch node here, and then I have the two debug windows, and I've named them accordingly. So essentially what we're doing here is we are sending in a number, and we are saying, is it greater than or equal to 100? Then you go to the first fork of the fork, and if it's the number, incoming number is less than 100, then you take the second path. So that's what it is. And over here another option is to, should it check all the rules or should it stop after the first match? So I've selected stop after the first match. You matched, it was higher or greater, you stop at that time. Okay, so let's have a look at what we are injecting here, and these are simply set up to receive a greater than 100 message number or a less than 100. So let's go here, and So we have a number here. Let me take that out first. Let's do something very simple. So let's say a number, and I have 101. Right, let's redeploy. Now when I click that, you can see that it took the greater than 100, right? It took the path 1. If I change this to, let's say, something less than 100 and redeploy, let's see, and as you notice, it took the less than 100. So the switch node, a very powerful way to, it acts like the if statement in any programming language. So it is able to evaluate depending on the logic that you have provided, and that can be quite extensive actually. You can see you have the value rules, you have, it can check for a key, a number between, it contains that expression or that number. You have a regular expression matching boolean, check for null, check for type, check for empty, not empty, and additionally the head and tail, and some JSON related test as well. So again, a very powerful core node that can help make this flow much more logical in terms of how you evaluating the rules. So let's do a quick let's add a random number generator, and we'll see how this works. So let's enter that expression, and let's do this. So every 5 seconds it's inputting a number. So this is a typical use case in any IoT or IIoT industry, that you getting an incoming message or a sequence every 5 seconds, and then you're deciding how it should be routed, right? So let's redeploy. Let me just clear the screen and let's inject that. So every 5 seconds we are inputting a number. So you can see the first one was a 12, the other one was a 32, the other one was a 92. So all of them have been less than 100 so far. And so we just checking 49. So all of them are less than 100. It's just generating that random number. So let's see. Maybe just to check that, we could perhaps change that sequence to allow for a larger number and see how that works. Let's clear the screen, and we should be getting some numbers that are larger than 100 as well. It's just generating a random number. So you can see that some of the numbers were less than 100, so it was routed to number 2, and some were higher than 100 and they were accordingly routed to greater than 100. So this was a example, a use case of how you can use the switch node in your flow, and as we shown here, you can use that to evaluate an incoming expression. It can be a number, and then send the data to another route as per your evaluation. So thank you for watching. I hope this was educational, and we covered the range node and the switch node. Both are very, very important nodes to understand and work with, and hopefully they will be very useful when you are designing your flows. So thank you for watching, and stay tuned for additional tutorials on Node-RED. Thank you.